Well, well, well. Looks like you guys did it. All of you wearing your pajamas inside out and whatever else you were doing. Here we are out for our first snow day slash remote learning. Anyway, let's make this real quick. You know the deal on remote days. Quick video, Nearpod links, do some slides, and a good old Google form quiz for you to take. If you pay attention, I think things will be pretty easy for you. Taking a look at my picture, you can tell how you can think that I feel about this. I'm not super excited because I don't think there's anything that I love more than being in the classroom with the kids that I enjoy the most, doing what I love to do, and that's teaching science. But anyway, we can still do it remotely now, so go technology. So we're going to continue to look at conduction, convection, radiation, insulators, conductors, those types of things. Let's go ahead and dig through this really quickly. As we've mentioned, like, what is heat? And we've learned that heat is actually a form of energy. And that energy is actually transferred between objects, especially if those objects have different temperatures. I mean, you can't have objects of the same temperature because they're not going to transfer any energy. When you have objects of different temperatures, it moves. And heat moves from the warmer object to the cooler object. If you kind of look in the background there, if you put a warmed plate, maybe it's been in the microwave, maybe it's been sitting on the stove, but if you put that on top of a cool counter, the plate is going to lose heat. The counter is going to gain heat. The heat is going to move from the plate to the counter because that's how heat moves. Heat moves from warmer things to cooler things. Oh, just a quick check in to see if Mr. Bullins is happy yet, and there's your answer. Conduction. Conduction is the passing of heat through touch. We went outside and we sat down on the sidewalk and we were touching the pavement and we felt the heat moving from us to the sidewalk. When heat moves from one solid to another solid through touch, you have conduction. So like when a pan is touching the stove and the pan becomes hot. Conduction. When you cook an egg in that pan that's touching the stove. Conduction. If you put an ice cube in your hand, you have conduction. We talked about the animals laying in that cool patch of dirt. Conduction. Those are all ways that heat moves through touch. If you burn your finger on the stove or burn your finger on a spoon that's in a cup of hot chocolate, which is something you guess you could do today if you left that spoon in there too long, all of those would be conduction. When you pick up a snowball and you hold that in your hand for a while, you're going to feel the heat moving from your hand to the snowball, and that is going to be through touch, so it's conduction. Don't forget, in order for conduction to actually happen, the two objects that are touching have to be different temperatures. Maybe you built a snowman and you put the big fat ball and then the one on top of that of snow, and those two snowballs that you're building the snowman out of, they're the same temperature. There's no heat exchange going on. If you put an ice cube on top of an ice cube, there's no heat exchange. They're the same temperature. However, when you put that snowball or that ice cube in your hand, the objects are now at different temperatures, and conduction can occur. Quick check-in. Yep, there I am. Still super happy. Convection. Transfer of heat through the movement of a gas or a liquid. We talked about this when we sat outside and the wind was blowing around us, and we said that we could feel ourselves getting cooler because the wind was taking the heat away from our body. And that's what we're saying right here in this next paragraph. If you're outside on a cold, windy day, your body loses heat to the air because of convection. And that's because the heat flows away from your body faster in the wind. And that's when we get those things like the wind chill factor, which I guess you could be feeling if you're outside and the wind happens to be blowing on a cold, snowy day. If you're boiling an egg in water, the heat is being transferred by convection because that's the movement of heat through a liquid. Anytime you have heat being moved by a gas or by a liquid, you're going to have convection. This is a boiling pot of water, and you're going to have hot water rising and cold water sinking. And we will look at that in an experiment, obviously, next week. Boiling an egg in a pot of water, the movement of thermal energy around the Earth. Again, we're getting closer and closer to that weather unit where we're going to talk a lot about this and things called convection cells. Anytime you're boiling water, the cold water sinks, the hot water rises, you have convection. There I am. That's how I feel. Radiation. Radiation is the transfer of heat through electromagnetic rays, or heat wave. When we sat outside on the concrete in the shade with the wind blowing around us, most of us got kind of cold, but when we moved into the parking lot, we could all feel the heat of the sun warming our face and warming our bodies. And it did that not by touching us, not through the wind, not through any kind of water. It did it through something called radiation. Even at 93 million miles away, we still felt the heat of the sun. And it was actually kind of comfortable to stand there and let the sun heat our face as we sat there quiet on those cool mornings and cool afternoons doing those experiments outside with conduction, convection, radiation. We were able to feel that. Nothing touched us. It was the sun warming our face through radiation. Here's a good picture of how the sun sends these heat waves. You can see it kind of waving its way, and it hits the Earth, warming up the Earth. Whoa, Mr. Bullen, how did you? I don't know how I did that. Radiation examples. Sitting by a fire and warming your face in the sun are two great examples of radiation. When you sit next to the fire, hopefully you're a little more excited than this girl, but when you sit next to the fire, you feel the heat waves. Heat does not move through touch. Heat does not move through a gas. Heat does not move through a liquid. Heat is moved through heat waves, and you can feel the heat when you're sitting beside of a fire, getting yourself warm. Something you might do after you go outside and throw snowballs and sled and build snowmen. Some more examples of radiation. Number one, when I found this picture, I said to myself, I really do want to ride this slide. It looks super fun. Number two, we all know that if we ride this slide in the summer, it's going to burn our backside when we sit on it. And that would be heat transferred through conduction because we would be touching the slide. But we have to think, how did that slide get hot to begin with? Well, here's this metal slide, which we know metal's a good conductor of heat, sitting outside on a hot summer day under the sun. Just like us, when we stood out in the sun and let the sun heat our face, the sun is constantly heating up this slide through radiation. So radiation is what causes the metal on the slide and the slide itself to become hot. And then when we sit on the slide and slide down, that would be conduction. But it's actually the sun's and radiation that makes the slide hot to begin with. Here's me again, not outside holding snowballs, not outside sitting in the snow making snowmen, looking at convection or conduction, or getting warmed by the radiation. I'm standing at the door, very angry. Conductors. Conductors are materials that heat passes through very easily. When a material lets heat pass through it, we call that a conductor. If you look in the background, you'll see this pan that's made out of copper. And most metals, like copper, are great conductors. And they heat up very quickly. And they heat up very evenly. It's not like one hot spot. The entire pan becomes hot and it's easy to cook with. So a lot of cookware is made with metal. If you're a good conductor, you're probably going to be a good pot or pan because you allow heat to move through you very easily. And metals are one of the number one choices, obviously, to make cookware and pots and pans out of. And you can see that this one is actually made out of copper, which is kind of cool. Iron, copper, gold, most metals are great conductors. And we talked about that in class, but what we didn't talk about was things like glass and ceramic are two other good examples. Casserole dishes are made out of glass and ceramic. I know when I'm making lasagna, I have to get like our glass, our casserole dishes out to put the lasagna in. And we layer things in that. We put that in the oven because, again, it's a good conductor of heat. Hey, just checking back in with you. Here's me staring outside, still angry. Insulators. Insulators do not let heat move through them very easily. Like if we're picking up one of those hot pans made out of copper with an oven mitt, that oven mitt is an insulator. It keeps the heat out or away from your hand. Insulators keep heat out or keep heat in. If you happen to have 4 pots sitting on the stove and somebody told you you've got to go pick one of those up, but you can't use an oven mitt or any other type of insulator, you have to pick up one of those. And you were looking at the 4 pots on the stove, and one of them had a ceramic handle, one had a glass handle, one had a handle made out of metal like iron, and one had a wooden handle. And you had to look at the 4 and determine which one am I going to pick up. Well, you got to start thinking, I need to find the one that's an insulator, the one that heat does not move through very quickly. Well, we know the ceramic handle wouldn't be good because ceramics are good conductors of heat. We know that glass would probably not be a good choice. Number one, because the glass might break, but the big reason why is glass is another conductor of heat. That glass handle would probably be hot. I think the iron handle is probably the worst choice because we know that metals are fantastic conductors of heat, and that's the one that would probably burn you the fastest because it would probably be the hottest. That wooden handle, however, that wooden handle is extremely interesting to me because we know that wood is an insulator and it's difficult for heat to move through wood. So I would pick up, and hopefully you would pick up the wooden one as well. I'm obviously going to leave the codes for you for this on here as well. That is all the notes that we're going to go over. Just a quick refresher on conductors and insulators and convection, conduction, and radiation. You can use your notes when you take the quiz today. You can use these slides. You can go back and watch it as many times as you want to. However, you probably shouldn't be spending much more than 20 to 30 minutes at the most on science today because it shouldn't take you that long at all because you know how this day rolls. All right, kiddos. I'll be staring out the window with lots of anger. You go out there and have a lot of fun once you get this stuff done. Don't forget to smash that like button and subscribe. I will see you on Monday.